Okay, this is Mr. Ho with your practice tests or the quiz that we went over today. I'm going to go over all the answers and hopefully you'll get 100% tomorrow. This was number 1. You want 12, a combination of 4. So I'm going to go to my calculator and just put that in. I have 12, combination of 4. And that gives me A. Alright. Okay. Number 2. Alright, this one is permutation where the order matters. So we're going to have 5 permutation of 4 things. That gives me 120. That's D. Next we have the combination of 4 things taken 2 at a time. Well, you would be all of these, the happy face and the sun, happy face and heart, and happy face and the triangle, and all the possible ways you can rearrange this, but the order does not matter. So I know that if I take 4 things, take them 2 at a time, I should end up with 6 items, so that would have to be B. Alright. Number 4. This is almost the same problem, except this is a permutation 4 things 2 at a time. There should be quite a few of them. There should be 12. Okay, so we have 4 things where the order does matter if we take them 2 at a time. And I get 12. So this is the only one with 12 items on here. If you make every possible combination of this 2 at a time. Next. Alright. Lifeboats. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters. And 9 letters can be arranged different ways. You can use 9 factorial here because none of them repeat. So answer for that one would be 362,880. Now let's do beginning. That also has 9 letters, but we have some letters that repeat. We have, let's see, the B's don't repeat, the E's don't repeat. There are 2 G's. So I have 2 G's. And I have 2 I's, and I have 3 N's. Okay, that'll give me 15,120. All right. Next. Okay. Amanda and Jessica are planning trips to 3 countries this year. There are 6 countries they would like to visit. One trip will be 1 week long, another 2 days, and another 2 weeks. Does the order matter? Of course it does. You want to spend your favorite place in the place for 2 weeks, and probably the place that you want to, you're least interested in for 2 days. So it's a permutation, and there are a total of 6 countries, and they're going to pick 3. 6 P3, and that will give me permutation of 120. Well, this problem kind of gives it away. None of the choices is permutation. So obviously this is a combination. But if you look at the problem, it just says 4 representatives picked out of 45 students. So the order does not matter. So if the order does not matter, that's a combination of 4. And that's going to be C. Okay, a gardener has 6 identical looking tulip bulbs, and of which they will produce different colored tulips. 3 of the colors are unknown, and 1 of them is white, and 1 of them will be yellow, and 1 of them will be pink. Okay, so the probability, she plants them arbitrarily in a row. That means she just, it's all mixed up. When the flowers start to bloom, what is the probability that the first one being white, okay, the first one being white, the first one being yellow, so there's a 1 out of 6 chance it being in the first place, and the white one, 1 out of 5 now, because one already came up yellow, and then the pink one is the last one in the row. So then we have 3 with 4 left, and then 2 left, 2 unknowns, and 3 left, 3 bulbs left, and then the last unknown, and then there are 2 bulbs left, and then the very last bulb that's left is pink. And if you do that, you get 1 over 20. Okay, a bag contains 8 real diamonds and 5 fakes. If 7 diamonds are picked from a bag, seven out of the 13 are picked from a bag at random, what is the probability exactly 5 of them will be real? So I want to choose 5 out of the 8 real ones, and I want to make sure I get 2 that are fake. So there are 5 fakes, and I need 2 of those. And if you do that, you get 140 over 429. Number 11, a bag contains 5 real diamonds. Sounds like kind of the same problem as the last one, but not really. And then 5 fake diamonds. 5 diamonds are picked from the bag. What is the probability that at most 3 of them are real? So that means I can have I have 10 diamonds, and I'm going to choose 5 of them. And then I could have at most, let's see, at most 5. So I mean at most 3. So that means I want 3 or less. So if they were 3 real, then there'll be, I need to choose 3 out of the 5 times, and I want 2 fake ones because I need a total of 5. Okay? Or I can have 2 real and 3 fake because I still need 5 stones. And then I could have 1 real and 4 fake, or I can have none of them real and all of them fake. If you do that, you should get 113 over 126. A class has 8 boys and 4 girls. If the teacher randomly picks 8 students, what is the probability she will pick all boys? So she wants to randomly pick 8 students. So she has a total of 12 students, and she wants to randomly take 8. What's the probability that they be all boys? And that would be 1 out of 495. Number 13. This sounds like almost the same problem. Class has 8 boys and 5 girls. If the teacher randomly picks 8, what's the probability that all of them will be boys? This actually is the same problem, except the numbers are a little bit different. So this is 13 of them, and then have 8 and 8 out of 8. That'll give me 1, 7. Number 14. One day, 7 babies are born in a hospital. So we have 7 babies, and assuming that the babies are equally likely being a boy or girl, what is the probability exactly 3 of them being boys? So, let's see here. We have there's a half chance that it's going to be a boy or a girl, and we're going to have 7 babies, so 1/2 times 1/2 times 1/2 times 1/2, and then we want 7 of them, or 3 of them, to be girls, right? Yeah, 3 of the babies to be girls, and then that will give me 35 over 128. Number 15. Joe is carrying 7 pages of math homework and 6 pages of English homework. And a gust of wind blows the papers out of his hands, and he is only able to recover 6. So out of the 13, he's able to recover 6. Order doesn't matter, so it's a combination. What is the probability that he recovers exactly 4 of the math? So he needs 4 math, but he recovers 6 pieces of paper. So we need 2 more pieces of paper, English papers now. So the answer is 175 over 572. 16, last one. Okay, a jar contains 7 black buttons and 6 brown buttons. If 6 buttons are picked at random, what is the probability exactly 2 of them are black? So we have 13 buttons, combination, the order doesn't matter, and we want to pick 6, and we want 2 of them to be black, so there's 7, choose 2, and then the rest of them are going to be brown, so if we're going to pick 4 out of the 6. And that's 105 over 572. All right, that's it. Good luck tomorrow. Study these.